Dear students, welcome to all. Myself Rambabu, Physics faculty from Nuclear Academy, Bangalore. In the previous session, we study about the Coulomb's law and related formula. Now, in this session, we are going to do problems on Coulomb's law. See here, the problems on Coulomb's law, which is depend upon the formula, that is force between any two charges is K into Q1 Q2 by R square. We will try to solve the questions with the help of this formula. So see first question here, if point charges Q1 2 into 10 to the power minus 7 coulomb and Q2 3 into 10 to the power minus 7 coulomb are separated at 30 centimeters, then the electrostatic force between them is, we need to find what is the electrostatic force between these two charges. So here we are going to use the Coulomb's law. Coulomb's law is given electrostatic force. The formula can be taken as K into Q1 into Q2 by R square. Here K value is nothing but 9 into 10 to the power 9 into Q1. Q1 is 2 into 10 to the power minus 7. Q2 is 3 into 10 to the power minus 7 divided by distance between two charges. Here separation between the two charges is given 30 centimeters. 30 centimeters means 30 into centimeters are converted into meters into 10 to the power minus 2 whole square, because it is R square. So simplifying this one, here 9 into 2 into 3 into numerator is 10 to the power minus 7, 10 to the power minus 7, 10 to the power minus 14. 10 to the power minus 14 plus 9, it is 10 to the power minus 5 divided by denominator. See how to do the simple calculation. 3, this is 10 is there. 10 into 10 to the power minus 2 can be written as 10 to the power minus 1 whole square. So if again simplifying this one, we will obtain it as 9 into 2 into 3 into 10 to the power minus 5 divided by 3 square. 3 square is nothing but 9 into 10 to the power minus 1 whole square is 10 to the power minus 2. 9 and 9 is cancelled. 2 into 2 is 6 into 10 to the power minus 5 by 10 to the power minus 2. 10 to the power minus 5 by 10 to the power minus 2 is nothing but 10 to the power minus 3 newtons. Now check the options. Here option B is the answer. So when two charges are given, we are going to calculate the force between two charges. Apply the Coulomb's law, F equal to K into Q1 Q2 by R square. And next problem. See, this problem is looking lengthy, but we do with the help of a simple shortcut technique. So try to understand this. First concept is understand. Suppose the spheres A and B of charges 6.5 into 10 to the power minus 7 coulomb. Two spheres A and B are having charges 6.5 into 10 to the power minus 7 coulomb, have identical size and distance between their centers is 50 centimeters. Now here two spheres are given. Sphere 1, sphere 2. Both spheres are identical. And here charge is given, both are having 6.5 into 10 to the power minus 7. For simple concept, I am going to consider this charge is Q, again this charge is Q. The separation between these two charges is 50 centimeters. Here they given in centimeters. That is the distance between these two charges. Okay, so this is the data they given. Next one. A third sphere of same size but uncharged. A third sphere can be taken of same size but it is uncharged. Then brought in contact with the first, then brought in contact with the second, and finally removed from the both. Then what is the new force of repulsion between A and B? So a simple concept. First, identical sphere is taken into contact. An identical sphere is taken in contact with the A, and after according to the conduction process, a neutral body, identical neutral body taken in contact with a charged body, both are acquiring the charge equal. So whenever it is separated, means whenever it is contacted and after removing, A is acquiring the charge Q by 2, and also third body is acquiring charge Q by 2. Again, that charge is taken in contact to the B. Already B is having Q, and whenever it is taken in contact with the third charge, net charge is Q1 plus Q by 2, but in this both are identical means both are acquiring equal charge. Equal charge is nothing but actually it is having total charge is Q plus Q by 2, then acquiring charge by B is total charge by 2. So finally, what about this charge? This is 3Q by 2 which is 3Q by 4. Like this we have to take. First, a neutral sphere is taken in contact with A, both sharing charge equally. Again, this charge become Q by 2, remaining Q by 2 is on this charge. Again, it is taken in contact with B, then total charge is nothing but Q plus Q by 2. And after third charge is removed, then B is acquiring half of the net charge. Half of the net charge is nothing but actually total charge is when they are taken in contact Q plus Q by 2, this is 3Q by 2 divided by 2. Remaining 3Q by 4 is on the third body. Correct? So finally the charge can become like this, and here distance we are not changing. Distance between them is same. So this is the very important point whenever this type of questions will be given. Understand, whenever third charge taken near, third body taken near, it is neutral body means and identical body means both are acquiring equal charge. So then charge of A become Q by 2, third body charge become Q by 2. Again, that third body is taken in contact with B, then also they can acquiring half of the charge. Actually, what is the total charge whenever third body is in contact? Q plus Q by 2. Because both are identical means both will acquire equal charge. Equal charge means half of that acquired by B. So finally, you can get the force now. Therefore, force is equal to formula K into Q1. Q1 is Q by 2. Q2 is 3Q by 4 divided by, what is the separation? 50 into 10 to the power minus 2 whole square. Okay? Again, K value can be taken as 9 into 10 to the power 9, and it is Q by 2 into 3Q by 2. It can be written as 3 into Q square by 2 into 4 into, it can be written as 5 into 10 to the power minus 1 whole square. Why I am writing, there is a purpose will be there, later you can understand. So here this is equal to 9 into 10 to the power 9 into 3, and what is the charge? Q is given 6.5. 6.5 into 10 to the power minus 7, because it is Q square, once again multiply with 6.5, 6.5 into 10 to the power minus 7 divided by 2 into 4 into 5 square is nothing but 25 into 10 to the power minus 2. And finally, we are going to simplify this as 9 into 3 into 6.5 into 6.5 divided by 2 into, here 4 into 25 is 100, 110 to the power minus 2 is cancelled. Finally, it is having only 4 into numerator 10 to the power minus 14 into 9, 10 to the power minus 5. So here you have to simplify this, you will get the answer. To simplify this one, I am going to take the multiplications like this. 9 into 3, 27. And 6.5 into 6.5. 6.5 into 6.5. 5 5 is 25. 5 6 30. 32. 6 5 is 30. 6 6 36 plus 3 39. This is 5 2 12 4 and it is 42.25. Again 42.25 multiplied with 27. Here 7 5s 35, 7 2s 14 plus 3, 17, 7 2s 14 plus 1, 15, 7 4s 28, 29. Again 2 can be multiplied, 2 5s 10, 2 2s 1 and 5. Here it is 4, it is 8. So finally it is 5, 7, 10, 14, 8 plus 11. And point can be taken as after 2 decimals. Here 1140 divided by 7.5. 1140.75 divided by 2 into 10 to the power minus 5. Now again we are going to divide with the 2. 2 can be divided 2 5s. 2 5s 10 and it is 14, 2 7s 14 and here 0 is there. Approximately it is 570 into 10 to the power minus 5 and here decimal point is only after 1 point or 2 points are there. So I am going to multiply with 10 to the power minus 2. It can be taken as 5.7 into 10 to the power minus 3 newtons. Here the value of the force is nothing but 5.7 into 10 to the power minus 3 newtons. Simple. Here we have to understand what will happen the charge between the identical bodies, and after simple calculation only multiply. Fast multiplication will give the quick answer. Very important model. So try to understand. And one more question. See this next one. This is also one of the important concept. See this. Two similar very small conducting spheres having charges 40 microcoulomb and minus 20 microcoulomb are some distance apart. Now they are touched and kept at the same distance. The ratio of the initial to the final force between them is. Here we have the shortcut. With the shortcut also we can do. First I explain the concept and after we do the shortcut technique. So here I am going to consider two charges. The first charge is 40 microcoulomb and second charge is minus 20 microcoulomb. Whenever these two charges are kept certain distance, then the force is 40 microcoulomb into 20 microcoulomb divided by 4 pi 1 by 4 pi epsilon naught. It can be taken as k and distance can be taken as r square. What they did in the second case, these two charges are taken near. When two charges are taken near, net charge become 40 minus 20, and here both are given similar. Similar means identical spheres. Identical spheres means they can share charge equally. Whenever both taken in contact, net charge become 40 minus 20, 20. After separating, first body is obtaining the charge 10 microcoulomb, second body is obtaining charge 10 microcoulomb. Understand, very important point. Whenever two identical, they given similar means two identical bodies taken into contact, then after separated, they can change the charges equally. What is the total charge? Plus 20, that can be divided as 10 and 10. But again, both are taken to the same distance. Here also, the same distance can be taken as r. Now new force, F dash is equal to K into 10 microcoulomb into 10 microcoulomb divided by r square. So like this we have to find. After that, what is the question they are asking? According to them, the question is nothing but ratio of initial to final force. Initial force is F, final force is F dash. Initial force is nothing but K into 40 microcoulomb into 20 microcoulomb divided by r square divided by K into 10 microcoulomb into 10 microcoulomb divided by r square. See, r square cancel, K and K cancel, microcoulombs are cancelled. Numerator is 40 into 20, denominator is 10 into 10. So finally, what is that ratio? 8:1. Here option A is the answer. But this type of problems, whenever distance not changed, the shortcut can be taken as F directly proportional to Q1 into Q2. F directly proportional to Q1 into Q2. So it is the shortcut. Because distance not changed, only charges can be changed. So what about this one? F1 divided by F2 is equal to initially charges 40 into 20. What are the final charges? 10 into 10. Similarly, value is 8:1. Simple concept. When distance not changed, then before taken into contact, what is the charge? Their product divided by after taken into contact, what is the charge? Take that ratio, that is given answer. This is actual procedure and it is the shortcut technique. Okay? And after that, we have to do one more question. Here, understand this one also. Two electrons separated by distance r. Two electrons are separated by distance r. Experience a force F between them. Whenever two electrons are taken, the force experienced by the two electrons is F. The force between a proton and a singly ionized helium atom. A proton and a singly ionized atom. Singly ionized means actually helium is having the two electrons. In that, one electron is removed. Now helium is having only one electron. Okay? Singly ionized means one electron is removed. Now it get ionized. It is having only one electron. And both are separated by 2r distance. Then what is the force between proton and singly ionized helium in terms of the F? First I am going to take case 1. Case 1 is given, two electrons are separated with distance r. Then force is equal to K into E square by R square. Similarly, case 2. Case 2, a proton. Proton is also having charge E and a helium. One electron is removed. Then this charge is also E. If two electrons are present, 2e. But it is singly ionized means it is having only one electron. Now distance between these two charges is 2r. So from that, the new force can be taken as K into E square by distance 2r square. Now in this situation, distance is varied. Previous question, charge is variable. Now we are going to take the question, what is the new force? Then F dash by F is equal to K into E square by 4r square divided by K into E square by r square. K E square by r square is cancelled. This is 1 by 4. Finally, what is the force between proton and singly ionized helium? F dash is equal to F by 4. Option D is the answer. So here why the force is decreases? Because of the separation increases. Charge does not changing, which is changing. For this we are going to take the shortcut. Here shortcut is nothing but force inversely proportional to distance square. Force inversely proportional to distance square. From that, F2 by F1 is equal to R1 by R2 square. Here F2 is force between proton and helium. F is the force between electron and electron. R2 is distance between proton and helium. R is distance between electron and electron. Finally, F2 is equal to F by 4. So we can follow this method or we can do with the concept. So like that, we have to find the force. And next question. See the next question. This is also similar to that, but we can directly observe two charges of equal magnitude and distance r exert a force F. Here two charges are given. Q and Q are separating with some distance. Then they given force F. F is equal to K into Q square by R square. Now, what they given? If charges are halved. Charges are halved means this charge become Q by 2, this charge become q by 2. And the distance between them is doubled. The distance between them become doubled means 2r. Then new force acting on each charge is simple. That is also previous two questions model. Previous that question is given charge changing. Before question is given distance changing. In this question both will change. So for that, what is the new force? F dash is equal to K into Q1 into Q2 divided by distance square. So once simplify this, you will get K into Q square by 4 into 4R square. Finally, this is 1 by 16 into KQ square by R square. What is KQ square by R square? Which is nothing but F. Therefore, F dash is equal to F by 16. Option D is answer. You can solve this with the help of shortcut also. F directly proportional to Q1 Q2 by R square. But it is the conceptual. Next question. Here, this is also one of the important but simple concept. Here, the given question, 2 point charges placed at a distance small r. 2 point charges which are placed at a distance small r in air experience a certain force. For example, I am going to consider two charges. Charge Q1, charge Q2 are placed in vacuum or air, and the distance between these two charges can be taken as r. Now the force is F. Force is nothing but K into Q1 Q2 by R square. Okay, this is the first case. See what they given next. Then the distance at which they will experience the same force in the medium of dielectric constant K. Now here this K is nothing but 1 by 4 pi epsilon naught. Here dielectric constant is given as K. That's why to avoid the confusion, I can write the full form 1 by 4 pi epsilon naught R square. Okay, na? Now in the medium, whenever this can be placed in the medium, when they are placed in the medium, again same force is exist, same charges are exist, but when they are placed in the medium, the formula is 1 by 4 pi epsilon naught into epsilon r. We can represent with one more term, that is also K. K also represent permittivity of medium, relative permittivity of medium or dielectric constant. It is known as epsilon r, or K also can be taken and distance is not changed. The distance is taken as x square, because force different when we kept in the same distance. But here what they mentioned, both are equal force. Then what is the distance between two charges when they kept in a medium? So I am going to consider this distance is x square. And here it is also written as Q1 Q2 by 4 pi epsilon naught into K. Epsilon r in the problem they given as K into x square. That is force in air, it is force in medium. But they ask the condition, that is at what distance the force between two charges in air and in medium is same. Then we are going to take equating both by equating Q1 into Q2 by 4 pi epsilon naught into K into x square is equal to Q1 into Q2 by 4 pi epsilon naught into R square. Simple, both sides 4 pi epsilon naught cancel, Q1 and Q2 cancel. Here x square taken this side, it is 1 by kx square is equal to 1 by r square. Take the cross product, x square is equal to r square by k. Therefore x is equal to r by root k. The distance in material or medium is equal to free space distance by root of k times. So like that we are going to find the distance between the charges in free space equivalent to distance between the charges in medium when both will experience the equal force. Option C is answer. X is equal to r by root k. And next question. Now here, understand the question again. Two identical copper spheres are separated by 1 meter in vacuum. How many electrons would have to be removed from one sphere and added to the other sphere that they now attract each other with force 0.6 newtons? Here in this given question, no new concept is there. You can go with the normal concept. What is the normal concept? There are two spheres are there. One sphere lost the electrons, another sphere is gain the electrons. Means one sphere is acquiring the charge q, other sphere also acquiring charge minus q. Because lost the electrons become plus q, gain the electrons become minus q. Then charge on each sphere. Here there are two spheres are given. And these two spheres have to be kept at a distance of 1 meter, and one sphere lost the electrons becoming it positive charge, other sphere gain the electrons becoming negative charge. So what about the charge value here? Q equal to Ne minus Q also Ne. How many electrons lost by sphere is equal to same number of electrons gained by the other sphere. Now here we are going to calculate to attract force between these two is 0.9 newtons. How many number of electrons are exchanged? Simple concept. I am going to use Coulomb's law. Coulomb's law is nothing but K into Q1 into Q2, that is nothing but Q square by R square. Substituting values here, force is given as 0.9 newtons, K value is 9 into 10 to the power 9, but they are asking number of electrons. Number of electrons means Q can be written as Ne. So this is the simple concept. So from that, divided by distance. Distance is 1 square. So finally it is Ne whole square is equal to 0.9 divided by 9 into 10 to the power 9. So simplifying this one, 9 ones, 9.1s. It is taken numerator 10 to the power minus 9, it is 10 to the power minus 1, total 10 to the power minus 10. So finally, Ne is equal to root of 10 to the power minus 10, which is equal to 10 to the power minus 5. But here question is, we need to calculate number of electrons. Number of electrons is nothing but N is equal to 10 to the power minus 5 by charge of electron. 10 to the power minus 5 by charge of electron is 1.6 into 10 to the power minus 19. So here number of electrons to create force between them is 0.9 newtons is 1 by 1.6 is, remember this is standard value, 0.625 into 10 to the power minus 5, denominator 10 to the power minus 19, taken to numerator 10 to the power plus 14. In this 110 is multiplied this, the number of electrons is 6 point, is there any 0.625? It is not there. All are with 6.25 into 10 to the power 13 number of electrons, that is option C is answer. So question looking little bit difficult, but do the calculation with the help of Coulomb's law. Okay? In this question they are going to ask how many number of electrons are transferred. To create the force between them is 0.9 newtons. Okay? See next one. Another one is important. The ratio of magnitude of electrostatic force and gravitational force for an electron and proton is. We are going to take the ratio of magnitude of electrostatic force and gravitational force. First, electrostatic force can be written. The formula for electrostatic force, K into Q1 into Q2 by R square. Formula for gravitational force, G into M1 into M2 by R square. Here the question is, what is the ratio of the electrostatic force to gravitational force of electron and proton? That is, the electrostatic force by gravitational force is equal to R and R. Distance is same, it is cancelled. It is k 9 into 10 to the power 9 into q1. Q1 is charge of what are the two terms? Electron. 1.6 into 10 to the power minus 19. Next to charge of proton. Same 1.6 into 10 to the power minus 19 divided by distance square divided by g value 6.6 into 10 to the power minus 11. This is universal gravitational constant, and mass is given. Mass is given as of electron is 9.1 into 10 to the power minus 31 into mass of the proton is 1.6 into 10 to the power minus 27 divided by r square. Here r square and r square is cancel, and finally we have to simplifying this one. Almost 9.1 no 9 no cancel, and here 1.6 and 1.6 is cancel. So finally what are the terms remain? It is remaining as 1.6 divided by 6.6, and numerator 10 to the power minus 19 minus 19 minus 38. Minus 38 plus 9. It can be taken as minus 38 plus 9 means minus 29. 10 to the power minus 29. And next one, denominator is minus 11 minus 31 is minus 42. Minus 42 and 27. This is 969. 10 to the power minus 69. When it is taken to numerator, 1.6 by 6.6 into 10 to the power 40. Not 40, 10 to the power 70, 30, 40. Nearly, that is 29 minus 69 minus 29, 40. 110 can be multiplied here. It is 16 by 6.6 into 10 to the power 39. 10 to the power 39, two values are there. 6.6 is not possible because 6.6 into 6 not equal to the 6.6. So 16 by 6.6 we can divide. 16 divided with 6.6, which is 4 by 3.3. 4 by 3.3 means 40 by 33. 40 divided with 33. 40 divided with 33 means, see how many times it can divide. It is, no, here 2 8s, 16. It is 80 divided by 33. 80 divided by 33 means 2 times. 2 times means here 2 point. So option is B. So like that, with simplifications we have to solve the how many number of what is the relation between gravitational force and electrostatic force. From that what we can understand, you can remember electrostatic force is 10 to the power 39 times of the gravitational force. Weakest force is the gravitational force, and one of the strongest force electrostatic force. Comparing to electrostatic force, nuclear forces are more strongest forces. Correct? So like that we have to find the ratio of the gravitational force and electrostatic force. And next one is, see here, two insulated charged metallic spheres P and Q have their centers separated by 60 centimeters. Distance between them is 60 centimeters. The radii of P and Q are negligible. That sentence is representing we are taking the distance between center of the P to center of the Q, which is 60 centimeters. Comparing to 60 centimeters, the radius of P and Q are not considerable. And next one is the mutual force of electrostatic repulsion between the two charges. Each is having the charge 3.2 into 10 to the power minus 7 coulombs. It is the direct question. They are going to ask what is the Coulomb's force. Coulomb's force is K into Q1 into Q2 by R square. Here K value is 9 into 10 to the power 9. Both spheres are having same charges. 3.2 into 10 to the power minus 7 into 3.2 into 10 to the power minus 7 divided by distance. Distance is 60 centimeters. 60 into 10 to the power minus 2 whole square. So simplifying this one, 9 into 3.2 into 3.2 into 10 to the power minus 7, and minus 7 is minus 14 plus 9. 10 to the power minus 5 divided by, it is 6 into 10 to the power minus 1. 6 into 10 to the power minus means 36 into 10 to the power minus 2. Simplification, 9 ones, 9 fours, 4 ones, 4.8s. That is 0.8 into 3.2 into minus 2 can be taken numerator, it become 10 to the power minus 3. So, and after multiplying this one, 0.8 into 3.2, 0.8 into 3.2, once we are multiplying this, how much value it is obtained? Once check, 9 is there. K into 9 into 10 to the power minus plus 9. Q1 is 3.2 into 10 to the power minus 7. 3.2 into 10 to the power minus 7. And here distance is 36 centimeters. 36, 6 into 10 to the power minus 1. 36 into 10 to the power minus 2. 9 ones, 9 fours, 4 ones and 4.8. And here 10 to the power minus 2, 10 to the power minus 2 minus 1, 10 to the power minus 3, and finally multiplying this, 3.2 into 0.8, 8 to 16, 8 3 is 24 and 1 is 25, 2.56 into 10 to the power minus 3 newtons. Option B is answer. 2.5 into 10 to the power minus 3 newtons. Okay. So like that we have to solve this question, and in this direct formula can be applied. Coulomb's law is applied, but calculation. And after that, see next question. Here a charged particle Q1 is at a position 2, 1, minus 3. The electrostatic force on another particle Q2 which is placed at 0, 0, 0 is. We are going to find the vector form of the Coulomb's law. Vector form of the Coulomb's law can be taken as the force between the two charges is nothing but 1 by 4 pi epsilon naught into, here vector form is given. So vector form is given, the formula is Q1 into Q2 divided by r cube in along r bar direction. Actually r cap can be written as r bar by magnitude of r. First we are going to take r. R bar can be taken as always the separation between, here force is acting on Q2 due to Q1. So here this can be taken as the initial point, where the force is acting, that can be taken as a final point. So charge which is applying force, it is placed at initial position, where the force is acting, that is final position, and it can be taken as R2 position, it can be taken as a R1. So here the positions can be taken as, this is final position R2 and it is initial position R1, where charge which is applying the force, that is the initial position, and where the force is applied, that is the final position. So from this we are going to take the R bar is equal to R2 bar minus R1 bar. R bar is equal to R2 bar minus R1 bar. So here R2 bar is nothing but 0. R1 bar 0 I cap, 0 J cap, like that. R1 bar is minus of 2 I cap minus J cap plus 3 K cap. So finally minus can be taken. The distance can be taken as minus 2 I cap plus J cap minus 3 K cap. So from this magnitude of vector can be taken, root of 2 square 4, root of 1 square 1, root of 3 square 9, finally it is root 14. Now substitute, you will get the final answer, which is nothing but Q1 Q2 by 4 pi epsilon naught into R value is root 14 whole cube. R value can be taken as root 14 whole cube, and it can be written as R to the power means R bar. R bar is nothing but here 2 I cap minus J cap plus it here, this is minus 2 I cap plus j cap minus 3k cap. And again here root 14 only there. When root 14 only there, I am going to write it as root 14 into root 14 into root 14. That is nothing but root 14 whole cube. So root 14 into root 14 is nothing but, it can be written as q1 q2 by 4 pi epsilon naught into root 14 into root 14 is 14, and one more for root 14 is there, into minus 2i cap plus j cap minus 3k cap. See final answer, q1 q2 by 14 into 4, 56 pi epsilon naught into root 14, and the direction can be taken as, here not root, direction can be taken as minus 2i cap plus j cap minus 3k cap. Once check the option, here option D is answer. q1 q2 by 56 root 14 into pi epsilon naught into minus 2i cap plus j cap minus 3k cap. So like that, whenever vector form of the Coulomb's law is given, first calculate R vector. Calculation of R vector means always where the force applying charge placed, that is the initial position, where the point charge is placed, which will experience the force, that is the final position. From that R bar equal to final position minus initial position. Okay? So very important model, try to understand this. And next one is, now here 2 point charges placed at a distance r in air exert force F on each other. The value of distance capital R at which they experience force 4F where placed in a medium of dielectric constant K equal to 16. Simple. First situation, force given, that is equal to 1 by, why 1 by means here K value given. That's why I am going to write like this. First they kept the object is in the air. In the air, the force is equal to q1 into q2 divided by 4 pi epsilon naught into the distance is given as a small r, which is small r square. Next one, in medium. In the medium, the force is given as 4F, the charges same charges. Now 4 pi epsilon naught into dielectric constant. Dielectric constant epsilon r, or also K can be taken into distance can be taken as capital R square. Now we are going to get what is the R value in terms of small r. For that simply we are going to take F by 4F. When F by 4F can be taken, Q1 Q2 by 4 pi epsilon naught into R square divided by Q1 Q2 by 4 pi epsilon naught into K. K value is 16 into capital R square. Q1 Q2 4 pi epsilon naught is cancelled. F and F is cancelled. 1 by 4 is equal to, taken 16 numerator, 16 into capital R square by small r square. Then 16 can be taken this side, it can be written as r square by small r square is equal to 1 by 64. Now taking root on both sides, r by small r is equal to root 64 is 8. Finally capital R is equal to r by 8, and here option C is answer. So like that we have to solve the question to calculate the value of a distance. So for that here the given condition. The condition is force in air is F, force in medium is 4F, whereas distance is capital R in the medium, small r is the distance in the air. So by using Coulomb's law, taking ratio of the two forces, you will get the relation between distance in medium and distance in the free space. And next question. See here, 4 point charges are placed at the corners of a square ABCD of side 10 centimeters as shown in the figure. The force of charge 1 microcoulomb placed at the center of the square is. So here whenever this type of charges are given, and these model questions are very easy. See how to get. Now here I place the 1 coulomb. Here I place the charge 1 microcoulomb. Then in between them, half of the diagonal, in between these two also, half of the diagonal is the force. Now whenever these two are opposite charges means the force is known as attractive force. That is taken as F1. Again these two are also opposite charges, again attractive force. Once observe here, magnitude of charges are same, distance is also same, here also same force is exist. Here two equal and opposite forces are acting in opposite directions, then both forces are cancelled. Similarly, when we are going to consider here, this is plus 3 microcoulomb and it is also plus 3 microcoulomb. And in this situation, repulsive force can be exist. It repel 1 microcoulomb in this direction, it repel 1 microcoulomb in this direction. But both are same charges and equal distance, it can be taken as F2, it is also F2. Both forces are again cancelled. So final answer is net force acting on the charge is 0. This is called symmetric structure. Later also we will discuss in the electric field, but learn whenever same charges are placed at the opposite, means equal charges are placed at the opposite corners, then net force and net field become 0. This is called symmetric structure. How it is, again we will discuss in the electric field also with the examples. And next one, see here, consider charges Q plus Q minus Q are placed at the vertices of an equilateral triangle and side length is given L. The force acting on the charge at A is, okay. See, it is one of the important model, board level also these model questions will be given. So see how to solve this question. And here this is the equilateral triangle is given and 3 charges are placed at corners. Now the corners can be taken as A, B, C. And 3 charges, those are, it is charge plus Q, here charge minus Q, again here charge plus Q. The distance is L, I can take another color. The distance is L, here also distance is L. See how to get the question with a shortcut technique or a simple technique. Now here, between the charges at B and at Q, both are positive charges, the force of repulsion is exist. I can take it as F. Next one is, it is plus Q and it is minus Q. Both are unequal charges, unlike charges. When unlike charges are given, what about the force? That force is nothing but attractive force. But once observe here, magnitude of charge same, distance between the charges also same, then magnitude of force is also same. This is first point. Next one, here they given equilateral triangle. When equilateral triangle is given, here this angle is 60 degrees. Then what about angle between these two forces? 120 degrees. Now we are going to find the resultant force. The resultant force is nothing but this is the resultant force. It is net force. See, what is the formula for net force? Net force is nothing but, I am going to apply the parallelogram law. According to parallelogram law, A square. A square means first force F square, B square. B square is also F square plus 2 into AB. AB means F into F cos 120 degrees. Substituting here, root of F square plus F square plus 2F square and cos 120 is minus 1 by 2. 2 and 2 is cancel, which is equal to root of F square plus F square minus F square. F square and F square cancel. Net force is nothing but any one of the force. Okay, now what about that force? That force is between these two charges or either these two charges. Then the force can be taken as K into Q square by L square. So final answer can be taken as option D. Remember this, whenever the angle between two equal forces is 120 degrees, then the net force is also equal to magnitude of any one force. Correct? Whenever 60 degrees angle is there, that is root 3 times of F. That simple concepts also we learn in the electric fields. Correct? So this is the procedure to calculate the force on the other corner of the any corner of the given charge which is placed at the vertices of given equilateral triangle. Correct? And next. So this is the previous question, last question. Once see here. 2 point charges A and B having charges plus Q and minus Q. So understand concept related to this. Here 2 point charges are given. It is plus Q and another point charge is given minus Q. Okay? Are placed at certain distance apart, some distance. That distance can be assumed as R. Then force acting between them is F. So here what is the formula for force? Is equal to K into Q1 into Q2, both are same magnitude, Q square by distance is R square. Completed. Next, what they given? 25% of charge of A. I am going to assume the first positive charge can be taken as A, negative charge can be taken as B. See what? The concept they given here, point A and it is point B, separation does not changing, but they change only the charge. See how that charge can be changed. Actually here charge is plus Q, here charge is minus Q. But what is the point they told? 25% charge of A is transferred to B. Transferred to B. Transferred to B means here 25% charge is removed. 25% is nothing but 1/4 part. And here how much charge is added? 25% of charge is added. 25% of charge from A is transferred to the B. Here 25% charge lost, that charge lost is added to B. So 25% means 25/100, which is 1/4 part. So here charge at A become 3Q/4. Charge at B become minus 3Q/4. Now we are going to take what is the value of the force. The new force can be taken as F dash is equal to K into Q1 into Q. Q1 is nothing but 3 into Q/4 into 3 into Q/4. My negative represent type of force only, but magnitude divided by distance not changing. Distance is R square. So finally it can be simplified. 3/4 into 3/4, 9/16 into K into Q square by R square. But K into Q square by R square is nothing but F. So it is 9/16 times of force, and answer can be taken as the option B. So like that we are going to solve the questions, but understand the point. 25% lost means in the charge 1/4 part removed, 25% is added means we can add the plus Q/4. From that charge on the A, charge on the B, again apply the Coulomb's law. Okay? So like that we are going to solve the problems on Coulomb's law.